Hello friends, as you know I started working on a new cylinder block for the Sachs EKF, so I have here a printed mock-up which I'm using for test fitting. I have made the primary cylinder design also here with all the exhaust ports, the A, B and C transfer ports, and I have test fitted it, and I have seen the need for a couple of adjustments, of course, which I'm working on right now. So anyway, I have bought this NTS crank. NTS have decided to also make these basically a stock crank but with 45mm stroke, which is exactly what I'm using for my project. So fits well in the block here, and then I found a good candidate for the piston. That is the same piston as they are using in the 50mm jog, so it's got holes in the back for that intake geometry which those cylinders are using. Using it now for the test and fitment purpose. So, hold on a second, putting in the bearing here, pin bolt, and then if I can make it fit, must be good, yeah, like that. You see here, oh, I managed to mess that up, oh wait. Come on. Yep. That's in. Then putting it in the block half. And then of course adding the cylinder. This I printed with 50.1, so plastic shrinking and all that. It fits actually like a proper honed boring. So what I found is that the piston itself needs a little bit, let's see here if you can see it. If I twist it like that, it should be possible to see, huh? Maybe if I hold it like this, it's coming down. Then the piston is a little bit long skirted as it is stock, and that is due to the geometry with the stroke, the length of the crank rod and all of that. So anyway, but what I have managed to perfect at the moment is, yeah, you can see the piston is exiting. Now there's no gaskets or anything, it's just pure fit to fit. So the piston is exiting about 0.1mm above, so that will be perfect for the gasket fit. So what I'll do now is take it apart again, of course. Sometimes it goes easy and sometimes not. I did, I can show you that also, because I did something here which most people usually forget, but it's this. You see, when the piston is on top dead center, we need to know that, let's see, can you see it? Barely. Okay, anyway, what we need to see is that the piston is covering the exhaust. I've used the triple exhaust design here, so it needs to be wide enough and long enough. So I was in there with a pen and scratched the lower part on the piston. Made a bit of a, you can see it there. So there is lots of material. So what I'll do now is take this down to my lathe and take off 4 or 5mm and test it again. And then maybe later, when this system here gets done, I have actually, as I make this video, I have shipped the drawings off to a CNC manufacturing company which I've done business with for many years. They are making me a CNC version of this. I will get it in a couple of weeks. And then I will install it. I have to finish my cylinder design and have it 3D printed and coated. And then we are back in the dyno and see how much power it makes. And of course, when this all works, I hope NTS at the time can make this crank here with a 5 or maybe even 10mm longer crankshaft, because then we can use the Yamaha pistons. I like them. They have a shorter deck height than this. You see here there's a lot of material above the pin bolt. I would like this pin bolt to be almost just below the bottom ring, so we have the perfect angle on the crank shaft at all time. Anyway, let's go down to the lathe and remove some material. Right, so there is my lathe, which I'm using for stuff like this. It's not the biggest one in the world, but for the work that I do, it is actually a perfect machine. This is the first time I will expose it to something as large as 50mm in diameter, so it's gonna be interesting to see. Should be able to handle that. No, fuck no. Okay, so I have to change these. Hold on a second. Okay, so I found these. These are for larger stuff. So this is marked with number 1. It should be down here. And then this is number 2. Should be up here. Then we have number 3, which, if I've done this right, should be here. Let's see. Right. First test. No. That sounded right. Okay, so yeah, that's not right. Let's try again. Okay, so I managed to change the vice here, or whatever it's called. It's called something. And then let's see what happens. Okay, so let's move you too, so you can see also. Yeah. All right. Switch on. That seems to be a little bit off. Okay, I need to do that again. That was better, I think. Let's see. So, center-ish. Center and off. Center and off, okay. Let's do some cutting, yeah? Manual cutting. Because why not? I think that would be good enough. Then definitely shorter. Okay, so let's do it with some. I thought I had a file or something here. Hold on a second. Good enough for now. That's what we call improvising. Okay, let's test fit it again. And as you can see, the bottom smile of the exhaust. So there's lots of material left. So that's good. Okay, back in my working area. Let's see what we can do here. Piston needs to come back on. Can you see this on this angle? Yeah, that's good. Bearing needs to be in. Then something like that. Then in here, let's see if it goes all the way down. Yeah, okay, so it does clear here, but it is a little bit wide, you see, so I need to make it. I need to take off some material here and there, so it will not collide here with the start of the transfer port. Or I could add material and grind away here, but I think I will do this modification in the piston, because ideally you want as little weight moving up and down as possible, so that's a win-win anyway. Alright, anyway, fits in here. You can see inside little, you can get an idea where it touches, starting area there of the transfer port on the inside. So I'll go and take that off also and try again. Okay, so for my next bit of machining, I think I'm gonna try my, it's basically just a drill, but this fancy little thing here from Vevo. I'm gonna test that for this. It might work, it might not, but it's gonna be fun testing it. Let's see what we can do here. It's pretty, it's all a little bit loose. Let's see, tighten it there, should be good. Give it some speed. Aluminum usually likes speed and shortcut. First side done. Okay, so I had to use the angle grinder to do it. Good old-fashioned angle grinder, never fails, especially for a small prototype like this. So let's see if it fits. This one will definitely do its job, but not in this. This is too flimsy for such work. Even though I got the right cutter and everything, this is just a tin tube made of, I think it's probably made of Majones tube or something like that, or recycled bicycles. It's perfect for drilling, but not for machining. Alright, done with the piston. So let's see if it will fit this time. It's supposed to be a tight fit, so if it still is, I've done something right. Go in here, and then let's see. Yep, clears perfectly. So then we can add the cylinder. You can see the mating surface there. I've cut out and stuff there. And push it in, 60 fits well, and then take it down and then up again. You can see here what's going on, can you? There, yeah. Exhausts open there. There's still a little bit print debris there, but anyway, you see what's happening. Transfer ports opening, A, B and C. So, alright. Then of course I have the other half too, right? So test fitted, 3D printed a mock-up of the bearing. So just a plastic one for the test. Puts it in here, fits well, and then here this one goes together under there roughly. There we go. Good fit, good clearance. I have ordered the parts which is going in here to test fit and verify that, so that will be good, and the wheel there, so that will also be good. So soon this will be available in a shop near you for finally getting the maximum power potential out of your old Sachs EKF. Stay tuned, I'll keep you updated, yeah? And have a good summer.